Hey, what's up guys, it's me Steven with the MacSpace. I got a repair over here. Customer came in, brought a 14-inch MacBook Pro A2442. What's going on? I'm gonna go ahead and let you see the overhead camera real quick. The MacBook Pro 14-inch, customer came in, stated that it was liquid damaged. Liquid damage is no bueno. It means this is going to more than likely be a board repair. More than likely means this probably will be. So what's going on is that the board does turn on, they said, and that they do not see any image on the actual screen. They said they removed the screen, they tested the screen on another MacBook, and that it does work. Not sure if that's the case. We will inspect it. They said they seen visual inspected liquid damage. Customer brought it in, kind of took it apart, looked at it, and brought it to us. So let's go ahead and see if we see any image. They said the screen works, they tested it works, so let's see if we see any backlight. Obviously, if it does not display, there's probably no backlight, but if they say the screen works, well, let's see if that's true. So what we're gonna do is we're gonna plug it up and see if there is any indication. See if the trackpad's clicking. Okay, trackpad's clicking. Let's see if there, oh, I see an Apple logo right there. Can't really see it too well, but let me kind of, you can't really see it, but I saw the Apple logo. So there's no backlight going on right now. We're gonna go ahead and not put any more power into this because we don't wanna make it worse, because corrosion will continue to build while there is electrical flow near the area and all the elements are just building up. So what we're gonna do is we're gonna go ahead and disconnect the battery, but before we do that, we have to open the bottom case. In order to open the bottom case of a MacBook Pro, you need a trusty handy dandy iFixit kit. This video is not sponsored by iFixit. It is just my kit. So I'm gonna go ahead and get that removed, that bottom plate, and inspect the board. Now, chances are, we don't know where this is the first time we're opening this, so we don't know what we're to expect. But what we're gonna do is we're gonna get a clear indication of where the liquid damage hit, look at that area, pull up the schematics and see what we can find. I also do apologize in advance that I cannot show you the schematic diagram on the computer, on the broadcast here, the actual video, because we haven't set up the actual secondary computer, which is a repair computer that has all the schematics and the board view. So, but not to worry, that is in the works. We're gonna get a capture card that captures that computer, expands it. Believe it or not, we're using a Mac Mini to capture this. For the next future videos, we will be putting that in where you can see the schematics and how I diagnose the board. For now, I will be diagnosing the board here visually and through the schematics on the repair computer and then go from there. Now what I like to do is turn it around this way because I like to keep the actual, here, and I'm gonna show you real quick. I like to keep the thing against my body so when I'm pulling up, it doesn't go anywhere and I can't force it and fly out of my hand. So what I do is I essentially keep it near me right here, I pull up and it snaps. And then I slide my fingers in the corner like this, grip this area and pull forward, and it slides right off. So yes, it looks like I don't see any liquid spill right now, but I see the liquid spill in this corner right here. Let's go ahead and turn it to the microscope camera. I see the corrosion right there. Looks like he tried to clean it up, but it doesn't seem like that's happening. Looks like it was clean, but it didn't solve the problem. So essentially, it looks like this board was cleaned, it looks like. The only thing I can assume is that there was maybe an alcohol scrub with a toothbrush, maybe. It looks like it's been scrubbed a little bit. I can see some scratches there. I can see, let me pull up my tweezers here real quick. I'm gonna show you real quick at the microscope. I see that this has been scraped a little bit right here. So this has been looked at and pushed. So there's that right there. That's looking like a nice little prize. So we see that area. Let's go ahead and let me continue looking real quick. Let's see what else we see. Looking on here. So essentially all this area has got liquid damage. This is liquid damage right here. So what I'm gonna do is I'm gonna look for the other side of the board. I'm gonna look for the other side of the board right here and try to see if there's anything else going on with this area underneath this. The battery disconnected, but we're not completely out of the woodwork yet. So let's disconnect the battery fully. Use a Torx 5 bit and remove the screw, the Torx 5 screw that holds the battery down, because I just don't trust that the battery is fully discharged or disconnected from the board. So what I'm essentially doing is guaranteeing that it is disconnected from the board. There might be some residuals here and there, but there we go. So we have disconnected it. So this area is what we need to look out for on the other side. So when we flip it, we'll see if there's any liquid on there. Good news is we do have a donor board in stock. So if we need to get some chips off the board, then we will. So let's do that. And also, since the board is, how do I say, liquid damage, if there is a capacitor that is messed up, we will see it, we will know, we will do a multimeter test, see if there's a short to ground. The board is turning on, which is good somewhat. It sees the Apple logo, so the NAND chips are working, so that's not that bad, but we don't know exactly fully what's going on until we diagnose it further, so I digress. Now, another thing is this customer really wanted the repair done pretty quickly, but we are backed up a little bit. So, myself trying to catch up. And with our employee, he is sick for the week. So it's been kind of a little more busy and trying to keep ourselves from being overworked with a lot of repairs. So the one thing about our shop is we stress quality of our repairs than quantity. And our repair prices are very competitive. We want to make sure that our customers are getting the best market value repair price, and whatever the market is, we try to beat that price and still pay a good living wage to our employee and make sure that we keep the lights on and make sure that we are able to survive, especially during the time that it's a lot more inflation and people are struggling and they can't afford to do a replacement of their laptop or a board repair. So we try to be reasonable. These repairs do sometimes they take a few hours. You gotta account for taking the board out, taking the bottom plate off, diagnosing it before you take it off. These things cost time and they do cost money, but we are understanding of, people's budgets, and we try to be that shop that does pay attention to that. And being a shop that does care about customers and their wallet. Most repair shops probably think that way as well. They probably don't say it, but we like to provide a good quality repair service, and it's also budget friendly. We can't, and some people, and I will say this is just personal opinion. If I was to walk into an Apple store, and this is just an opinion, and Apple quoted me, they don't even do board repairs, but they quoted me a replacement of my board. And my board cost $700 to replace, or $600 or $600 to replace the board. They send you another board and you send the board back to them, blah, blah, blah. But your data is so important. Apple quotes you out of warranty or accidental damage. And I don't hold me to their prices, because I don't work for Apple, nor are we endorsed by Apple, and nor are we affiliated with Apple. However, this is an opinion that if I was going to walk into an Apple store and I get a price quote, and this is from customers, and these are their opinions, I can't verify, but they do say this, and these are customers that come from Apple. They say like, this is a lot cheaper, but they say it's like $700, and essentially 600, 700, maybe 500 depending on the board and the specs to replace your board, but you lose your data. If I come to a third party that specializes in repairs of Apple products, and they don't guarantee me, but they have a high success rate of board repair and recovering your data, because recovering your data, you have to fix the board. You have to get the board to turn on, and then you get your board repaired and you get your data recovery. See, look, there's liquid damage right here. And it costs you the same price, essentially getting data recovery and then the board repaired, and you're getting the same price. It's essentially you keep your data, but you keep your board for how long it lasts, like years. I feel like that's a better solution and a win, because you're essentially paying the same price of replacing your board, but you lose your data. But essentially, we usually are cheaper than replacing the board, because that's the goal, is to be cheaper than replacing the board. This is how you know that that person that pulled his board apart did not really take the board out, because they did not want to deal with it. Essentially, put all these, I put them back on too, so I put them this side, I slap them right back on where they come from. Kind of weird that Apple put these little things there, because I noticed that the M2s or the M3s don't have these rubbers there anymore. Maybe it's a cost thing. Put these four together. There we go. All right. I think we got every screw, so let's go look real quick. Yeah, that's removed. Make sure everything's removed before we try moving it. That's disconnected, that's disconnected, that's disconnected, that's disconnected, that's disconnected. All right, so let's move this up. We don't want this to get caught. So I like to bit it in place. This is the lid sensor, backlight, and it's turn on and turn off, but the lid sensor does make the computer act funky. So we're gonna pull it from this side. Anything there? See that area? Do y'all see anything? Okay, cool. So let's find out what that area is. Pull up the board schematic. Pull this up. So I spot that liquid damage right there. What do we have up here? Now this is where the backlight is on the other side connected. So, and that chip is burnt out. Now, I think capacitor here is, oh. Let's see if they're still soldered on. No, they're not destroyed. This guy definitely gives me some suspicions of why the backlight is not working. Go ahead and desolder this area. I'm gonna remove this chip off because we're just gonna remove it. I think it's a good idea to go ahead and remove it. And after we get it removed, we'll do a quick board cleaning. Also, I like to get all the flux in this area because, you know, why not get this flux to come down. There we go. Go ahead and remove this chip. Remember the orientation, guys? You can see all the letters right here facing this direction of a donor board that used to work, and we just removed everything. Look at all that. Look at all that stuff underneath that chip right there. Look at that. Nasty, nasty, nasty. Got all that liquid spill right here. Much better. Okay, so what we're gonna do is we're gonna get a Q-tip, some alcohol, wipe it up first before we start stringing along with the solder wick. You can get any stuff off this area. Look at that. Nasty. Doesn't want to come off. Okay. We'll make you come off at 50. Use 425 degrees Celsius because that's what I like to use. Give them an area. Not done yet. I see there is a little bit of, and look at this area. Some of the corrosion ate that pad right there. And this is why I didn't want to scrub it, because underneath that area, you see the pad right here. That area is getting eaten away from the corrosion that was caused by the damage of the liquid spill. This is the donor chip we're taking off, and then we're going to reball it. So we're going to be very delicate with it. Part of the reballing process is actually wearing gloves. We need to get trusty, handy, dandy leaded solder. Again, I say this every stream or every broadcast. Do not handle leaded solder with your bare hands. Wear gloves. Always wear gloves. Now, we're going to reball this, so we have to find a stencil that would fit that chip. Plenty of stencils that might work. We just need to find the right area. So let's see. I like to turn it on its side. Be very delicate with it because we don't want to crack it. So that is 6. Give us 6 here. So let's go over to the 6 right here. This looks like it is, yep, this one will work right here. Well, most of it. That works. That's fine. That is fine. Going to put this bad boy down. There we go. Sits perfectly in that little hole. Use some tape I already had there. There we go. Set the temperature down to 375 degrees Celsius. Put the air down to 1. Airflow down to 1. Why do you need to put it to 1? Because you don't want to blow the solder all over the place. You want it to build up and form, not fail. Okay, so look at that. Not too close. Nice and steady. Okay, I think that's good. Oh, we can. Nice. Go. And then we do one more little. Let me just grab all the balls. Okay, balls on there. So they merge into it. We don't want any solder balls on there. We want them to absorb into each other. That's not fast enough. So we'll do a 10. That should be fine. Okay, last thing is clean it up. I'm a perfectionist, so I like to get the balls off. So when I put it on, there's nothing in my way. Good. Put a little flux in that little area. Whatever. Yeah, it's a lot. Whatever, it doesn't matter. There we go. Now, raise it up a little bit more because it's holding, but it's not done. We need to see it move a little bit. It doesn't look like this is blown. So I'm just gonna clean it, see if it moves. If this went out, the fan would be spinning like crazy, probably, or it would not be spinning at all. That doesn't look bad. That looks good. Just a little bit of corrosion's gone now, but it looks like it's been cleaned enough to trust that it's working. All right, let's turn the other side over. Okay, so this other side is a concern because this usually indicates that there's a fair issue. Now, if the computer continues to persist on not turning on, you know it's this area right here. Let's see if it's eating it. Nope, still there, still good. Still on the board. Make sure that's not eating away. Still on the board. This right here looks like a problem. That one too. Okay. Capacitors on that one are blown. That's why I was having problems with the tweezers. It wasn't ripping it off. That's fine. That one's bad. That one came right off. Look at that. It's stuck in me. Doesn't even want to come off. And this one, there we go. Look at that. Came right off. Same thing. I do this when it comes to the pads, but not like the thin ones. I usually just run this guy through to pick up the excess. Cool. And then we add some new solder wick solder. There we go. Fun, fun, fun. Now, these shouldn't be a problem coming off because they're not damaged. So let's remove them. Okay, cool. Got two of those off. Let me clean this up. I do suspect that there's something going on with the board moving forward from here. This chip right here, this chip, like this one right here, would be the next thing I would have to diagnose, but I would replace it if that was the case. All right, let's take our gaffing tape off. So before I proceed, I had to take the board out again, and I thought everything was good, but I did not realize that there was still a short of the board, and I found the short. I removed it. I'm gonna show you guys real quick. Capacitor right here was shorted to ground, and I did a quick check onto the board, and then as soon as I removed it, it went away. I also removed the LCD backlight driver just to verify, and it still was shorted. I removed it, the short went away. So that capacitor was bad. I went and replaced it. I'm gonna go ahead and replace it. I took the donor off there. I checked this capacitor is not shorted, but it doesn't look good, so I'm gonna go ahead and replace that one as well. So I'm just gonna go ahead and replace these two capacitors. I already pulled the two other capacitors off the donor board, so I've got them ready to solder on. So I'm gonna go ahead and remove it and go ahead and make this repair complete, hopefully. I do know one thing is that when I did put the board back in, the computer did turn on. It did not boot loop anymore. The backlight, the keyboard's backlight came on. So that means it posted this time. So that boot loop process has went away, but we still have the backlight issue. So what I'm gonna do is I'm gonna move this other capacitor off the board. Okay, I'll go ahead and get rid of that. I'm gonna go ahead and add some new leaded solder to this, so it's a little bit more easier to work with. Okay, put this on. Your grip. There it goes. There's that one. Get those ready. Okay. All right, let it grab. Add a little bit more flux again. There we go. Nice. Always for testing for shorts to ground, red probe to ground, black probe to the positive side of the capacitor. Oops. Let me clean that up a little bit so y'all can see. Looking really clean now. So go ahead and put this black probe over here. Put the red probe right here and the black probe there. Okay, that's good. No noise. This is normal. These always result. These are grounds. So this is right here. This is positive and it's not shorted this time. Anyways, so here we go. Let's go and check this one more time. That's normal. It's a ground, of course. I have this bad habit of testing this area to make sure. That's ground. Those are ground. That's a ground. That's a ground. That's not. It's not. That's not. It's good. That's good. That's good. It's ground. Good. All right, that short has been removed. So let's go ahead and put this back. That short has been removed. So let's go ahead and put this back over. I got the chip reballed and I put it back on. I actually reballed a little bit better this time. And I'm checking this short and let's see. So let me show you that this is working. And now we're gonna test this area. And the short is gone. All right, I have a little bit more confidence that this backlight is going to turn on now. So with that said, now I'm gonna clean it up a little bit and test it and then make sure it works and then put it into the cleaner. If this does not work, then we have to get a new chip because the short has been removed. And we have to get a new chip because, well, we have desoldered a few times, but I have confidence it's going to work. So I'm gonna go ahead and stop this for a second and then put the computer back together and then it should work from there. All right guys, I put the board back together. So I'm gonna go ahead and test it. And oh, now, there we go. Oh, there it is. There it is. Let me do this real quick. You see the Apple logo, it's loading. Everything's working. We are good to go. We have fixed the backlight. So there's that. Oh, well, it says it's a macOS recovery. We did get, the customer did call us to let us know that he left the computer in recovery. So I'll let the customer know, give them a call, let them know that it was a successful repair and that their data is there and everything's good to go. Thanks for watching.